So, today we're going to be dealing with a thing called common factors. And what I want you to think about is this. If I take any number, let's say I take 16. Okay, if I take 16 and I use an algorithm on it, I could take 16 and find numbers that divide into it. So what I'm going to do is I'm going to take this 16 and I'm going to take a number and I'm going to divide it out. So the easiest one I'm going to take out is a 2. Now, 16 divided by 2 is 8, isn't it? Okay, so it's 8. But then 8 can be divided by, well, 8 can be divided by 2 again. And then 8 divided by 2 is 4. But 4 can also be broken down again into 2 and 2. That's interesting. Well, let's try that again. That's interesting. So if I keep dividing by the smallest number that divides into my number over and over again, I'll end up with these endpoints on my graph, on my chart here. Now, what you want to do is I'm going to give you another problem. We'll try it out. Let's try 450. Now, I could tell you right away that 450 is divisible by 3. This is just a trick. If you think about it, basically just add up all the digits of our number, 4, 5, and 0. The total is 9. 9 is divisible by 3, therefore, this thing is divisible by 3. I know I could have divided this by 0 because of the magenta, the last number on my 450 is a 0. I could have divided by 2 or possibly 5. I just chose not to. But let's start with 3 instead. So now 450 divided by 3 is going to be, well, 150 times 3. Now, 150 is divisible by 2. So let's do that right now. 150 divided by 2 gives 75. 75, because it's magenta, its last number on the thing is 5. We can divide it by 5 again. 75 divided by 5 is going to be 15. 15 divided by, well, oh, hey, there's a 5 there. I'm just going to divide it by 5. And then we're left with 3 here. And you'll notice from the first graph, it says, if I look at the endpoints, this is actually telling me on the first graph 16 is equal to 2 times 2 times 2 times 2, otherwise known as 2 to the 4. But you notice that each of these numbers here are prime numbers. And if you look here on our second graph, our second calculation, we have 450 is 3 times 2 times 5 times 5 times 3. What I'm going to do is I'm going to organize these into something a little bit more readable. So let's just first start by writing it out. 450 is equal to, well, I got a 3 times a 2 times a 5 times a 5 times a 3. And what we're going to do is we'll just pull everything together. So we got Let's put all the 2's together. There's two 3's here, so it's 3 squared times, well, 5 squared. Okay, so what this shows us is that these numbers are products of primes. Prime numbers. Now, you can use this idea to help you calculate the actual greatest common factor. You learned about this a long time ago, but the reason why we're able to use this thing called greatest common factors is because every number that is out there in the world is a product of primes. Every single number. Now, every prime starts with 2, possibly 3, 5, 7. The most you'll probably see is something with a prime of 11 in this course. Anyway, now I want you to quickly go on and do the lesson.